Now, my dear friends, we can see question number 31. In the reactions S plus 3 by 2, SO3 plus 2x kilocalorie and SO2 plus half O2 to give SO3 plus Y kilocalorie. The heat of formation of SO2 is. And what is the calculation, my dear students? Here we can see the concept and calculations. Concept. Here's S plus O2. Number one equation here, S plus 3 by 2O2. It's a required reaction to give two reactions are there, no? SO3 plus 2x calories, means it's a given reaction. Number 2 is the SO2 plus half O2 to gives SO3 and it is the Y kilocalories. Now, my dear students, heat of formation of SO2 means required reaction. Here we can see the required reaction here. Here required reaction is the heat of formation of SO2 means sulfur plus O2 to give SO2. This is our required reaction. Heat of formation S plus O2 to give SO2, this is our required reaction. Now, this reaction is required by this 2. So, my dear students, when this is 2x and this is the y, and we get this section, here you can see this is in reactant, yes, this is reactant. So, you can write this section, yes, we can take as it is. This is a trick also. This is in reactant, but this is present in product. So, my dear students, you must reverse this section. You must reverse second reaction. So, my dear students, here you can see that when reverse this second reaction, you can get the SO3 to give SO2 plus half O2. When you can reverse this section, then this Y kilocalorie is also reversed. It is converted to minus Y kilocalories. Now, we can see here, we can add, when we can add both reactions 1 and 2, reverse this section. After reverse this section, we can add. You can get the SO3 is present in reactant side and here SO3 is present in product side. So, both are cancelled and here SO2 is present in the, means first you can write here reactions first of all, then these are easy for you. After the reverse, you can write first reaction also. First reaction S plus 3 by 2O2 and this is the SO3. You have not changed this reaction, this is a plus 2x. Now, we can see here and obtain this reaction. SO3 and SO3 cancelled and here, my dear students, you can get here this sulfur plus this oxygen half O2 and 3 by 2O2. Means these are the cancelled and after the cancel you can get only O2. My dear students, when you can get that 3 by 2O2, it means it's a 3O and when you can get the half O2, it means it's a 1O. So, my dear students, you can see here half O2 is cancelled by 3 by 2O2 means 1O cancelled by here 3O, 1O. So, you can get only O2. What is the O2? O2 is a twice O. So, by this concept, you can apply here and get that S plus O2 to give here SO2. You can see here same reactions are present, targeted reactions achieved when you reverse this reaction. So, you have 2x minus y. When 2x minus y, then you can get this heat of reaction 2x minus y. And So, my dear students, question number 31 answer is D, that is 2x minus y, and you achieve the reaction. I give you this concept as well as trick. This is also trick, my dear students. Now, we can go to the question number 32. Here given that C plus O2 CO2 delta H minus X twice CO plus O2 twice CO2 delta H minus Y, the enthalpy of formation of carbon monoxide will be, first of all you made the reaction, target reaction. You can see is target reaction. What is the target reaction, my dear students? Carbon monoxide, formation of carbon monoxide. Carbon plus half O2 to give carbon monoxide. This is our target reaction. And my dear students, we can achieve this target reaction by the two reaction, which is given by question, which is given in question. Carbon plus O2 to give CO2, delta H is equal to minus X kilojoule. Here carbon is in reactant side, CO2 product side. Here you can achieve this carbon in reactant, no problem. But you can see this is the reaction number 1 and this is the reaction number 2. In reaction number 2, you can see here carbon monoxide is present in reactant side and carbon dioxide is present in product side. Here you can want the carbon monoxide in reactant side. Why? Because in target reaction this carbon monoxide present in product. So, you can reverse this reaction. First of all, we can reverse this reaction. So, when reverse this reaction, we can get twice CO2 to gives twice CO plus half O2, and then delta H, when this reverse minus Y is converted to plus Y kilojoule. Here you can see that one CO is present, but here you can see twice CO is present. That is why you can divide it. You can divide it by 2. When you can divide it by 2, then you can get the, you can divide it by 2, 2 and 2. Then you can get 1 CO. So, this whole reaction is divided by 2. So, my dear students, perhaps we can get this target reactions. When these are divided by 2, 2 cancelled, CO2 is present, 1 mole of CO2 cancelled by this, here 2 cancel, you can get only CO, and here in this reactants no CO is present. So, you can get CO, and this is the half O2. So, half O2 is cancelled by this O2 and you can get only half O2. So, my dear students, you can get the target reaction C plus half O2 to gives here CO, and this target reaction you can achieve when heat is plus minus X plus Y by 2. Then you can achieve this heat, or you can say this Y minus X by 2. Then you can achieve this reactions, delta H of monoxide, formation of carbon monoxide. So, my dear students, this is your answer, Y minus X upon 2, Y minus X upon 2. Here you can say minus X plus Y by 2, Y by 2. Here you can see that here this Y minus 2X upon 2, you can also, it is converted to Y minus 2X upon 2. Then 2 से 2 cancel, then you can get the Y minus Y by 2 minus X. Both are same thing. So, you can go to the answer A, question number 32. You can get the answer A. Y minus 2X upon 2 or Y minus X upon 2, both are same thing. So, my dear students, if you get this, and you can get the target reaction in this way, and this is a trick and target reaction and tricks. You can get question number 32, your answer is A. Now, my dear students, we can go to the question number 33. Here 33, If enthalpy of formation of methane, CO2 and water liquid are 1 atmosphere are 52 minus 394 minus 286 respectively, then enthalpy of combustion of ethane will be. Here, what is the trick, my dear students? You can solve the trick and concept this question. First of all, he want the enthalpy of combustion of C2H4 gas. Here your target reaction is C2H4 is heated by oxygen, all carbon is converted to carbon dioxide and all hydrogens are converted to water. This is your target reaction. Here thrice O2, 1 mole of C2H4 gas. Now my dear students, here we have enthalpy of formation of C2H4, number 1, means 1 mole of C2H4 is formed by its constituent, that is twice C plus twice H2, and enthalpy of formation is 52 kilojoule per mole. Now we can see here number 2, enthalpy of formation of CO2, 1 mole of carbon dioxide is formed by carbon plus oxygen and you get minus 394 kilojoule. Number 3, enthalpy of formation of water, 1 mole of water is formed and enthalpy of formation minus 286 and hydrogen plus half O2 is taken. Now my dear students, we can see here that we can achieve this equation, target reaction, by these 3 reactions. Here you can see which are present in reactant, which are present in product. Here you can see this is present in product CO2. Here you can get twice CO2. So you can multiply by twice, this heat is multiplied by twice. Here you can say twice H2, so this heat is multiplied by twice. So you can get twice CO2, twice H2. Here my dear students, this C2H4 is present in reactant side, but it is in product side. So this reaction is reverse reaction. So plus is converted to minus 52 kilojoule. Now we can edit all the reactions. Then you can get this target reaction and get the heat of formation, heat of combustion of ethane. That equal to first minus 394 multiplied by 2, it is plus minus 286 multiplied by 2. Here this is minus 52 kilojoule. So my dear students, when you can multiply 2 plus and multiply by 2, minus plus, it is added, then you can get the minus 1412 kilojoule per mole. So my dear students, it's a heat of combustion of ethylene, and you can solve easily by trick. It is not required to give the all equations and cancel with each other, because we want in this crash course, in this NEET exams, target is that you can get the answers in easy way and which trick is applied, and you cannot expensive time in these questions. Now we can see here question number 33, answer is 1 minus 1412 kilojoule per mole. So my dear students, question number 33, answer is D. Now we can go to the question number 34. The bond dissociation energy of X2, Y2 and XY are the ratio of 1:0.5:1 and delta H for the formation of XY is minus 200 kilojoule the bond issue energy of X2 will be. Here what is the trick which are apply here? Bond issue energy of X, bond enthalpy of X2, Y2 and XY. X2 is the 1, here X2 is the 1, here Y2 is the 0.5. If you can get this X, if you can get the X2, X kilojoule, 1 means X, here 0.5 X and here this is X, kilojoule per mole. Then now we can get the dissociation energy, that is half X2 plus half Y2, and you can get the XY. This is the formation of XY and delta H for the formation of XY, that equal to minus 200 kilojoule. So my dear students, that delta H is equal to minus 200 kilojoule. Because this 1 mole of XY is formed by its constituent, so we can write here half X2 plus Y2, half Y2 to give XY. This section we can write here. Now my dear students, you can see here what is the values delta H. My dear students, for delta H is the summation of enthalpy, means bond enthalpy of the reactants, this is a formula, minus summation of bond enthalpy of product. So my dear students, you can see here reactants and products, here these are the products, and we can summation of this, we can put the values. Here this is the half X2, means we can put the X, half X, so value is X, we can put here, plus half, we can put the values of, this is Y2, that is 0.5 Yx, and here this is the reactants, bond enthalpy of reactants. Now minus and summation of bond enthalpy of products. Now here bond enthalpy of product is the X only, here we can put the 1 into X. So bond enthalpy is that equal to delta H, which is given minus 200 kilojoule, you can put the values, that equal to half X plus half into 0.5 X minus X. So you can solve this X values, my dear students. So bond enthalpy of X2, that equal to, you can get the, this is the bond enthalpy of X2, you can get the X, that is the X, and this X is obtained by these equations, and you can get the 800 kilojoule per mole. So my dear student, this is your answer, 800 kilojoule per mole. First of all, we can solve these equations, we can put the bond enthalpy's values, and you can bond dissociation energy of X2 will be, he asks, X2, Y2 and XY is present in a molar ratio, you can put the molar ratio, then he give the heat of formation, then you can get the reactions, heat of formation reactions, then this is the formula, my dear students, and you can use this formula and learn this formula. In this formula you can see the bond enthalpy case, bond enthalpy of the reactants are always negative than the bond enthalpy of the product, and you can get the delta H. So my dear students, you can get the delta H when we can put the bond enthalpy of reactants minus bond enthalpy of product. Here we can see in this formula, reactant minus product is given and delta H is also given. Delta H is the formation, means this is the reaction. Delta H is the heat of reaction or heat of formation reaction, because 1 mole is formed XY. That's why it is called heat of formation. Now we can go to the question number 35. Here 35 question, the heat of combustion of carbon to CO2 is minus 393.5 kilojoule per mole. The heat released upon formation of 35.2 gram of CO2 from carbon and oxygen is. We can see the theory and concept. Carbon solid plus O2 gas to give CO2 gas, delta H, it is given by, because there is a carbon, heat of combustion of carbon, this is the reaction, heat of combustion of carbon, delta HC, that equal to, which is given by minus 393.5 kilojoule per mole. This is our first reaction, my dear students. Now we can see amount of heat released on formation. We can see the amount of heat released on formation of 44 gram CO2, because here molecular weight of carbon dioxide is a 44 gram. So when this 44 gram of CO2 is formed, amount of heat is released, that is, my dear students, 393.5, because delta H represented by minus Q, and when heat is released, it is given in positive sign. For the heat, it is a positive sign. So it is called 393.5 kilojoule per mole. This heat is released. Now, amount of heat released on formation of CO2, on formation of 35.2 gram CO2, that equal to 393.5 multiply by this 35.2 and divided by 44 gram. So my dear students, you can get 314.8, approximately 315 kilojoule heat is released. So when this is called heat released, then you can go the answer heat positive sign, you can get the positive sign. So this is a plus 315 kilojoule is the answer, because here in question heat is released upon formation of. So answer is A. Now my dear students, question number 35. This question is also asked in 2015 NEET exams. In this type of question, you can solve in this way. First of all, you can see what is the amount of heat released for 1 mole of the weight, and that amount of heat released. So hence, which weight he want, 35.2 gram of CO2 heat released. You can easily solve this question. Now question number 36, my dear students. When 5 liter of gas mixture of methane and propane is perfectly combusted at 0 degrees Celsius and 1 atmosphere, 16 liters of oxygen at the same temperature and pressure is consumed. The amount of heat released from this combustion is Kz delta H combination methane 890 kilojoule per mole and delta H combustion C3H8, that equal to 220 kilojoule per mole is. My dear students, question number 36 in this question, we have solved these questions. Slightly this question is a lengthy questions, but this question is asked in NEET 2013. So we can, here this question is solved. You can see proper two gases are there, methane and propane, number 1. Number 2, my dear students, atmosphere pressure is 1 and mixture of volume is 5 liter and oxygen is 16 liter is added, and this is consumed by the methane and propane. And question is asked amount of heat released by two gases, methane and propane. So he want the heat of combustion, and my dear students, heat of this combustion methane 890 kilojoule and propane 2220 kilojoule 2220 kilojoule per mole is given in this question. So my dear students, 4 to 5 data are there in this numerical. Now we can solve these questions. Here we can solve question number 32. Solution. Question number 36. Here my dear friends, number 1 equation is that methane gas plus twice O2 to give CO2 plus twice H2O delta H combustion, which is given in the numerical, that is 890 kilojoule. Now we can see the second equation, propane. Propane is a C3H8, heat of combustion, that is CO2, thrice CO2 you can get, and plus 4H2 and delta H combustion, that equal to, given in numerical, 2220 kilojoule. Here my dear students, now we can take the this equation given. Now here we can take the methane. Methane, we can take the X, and propane C3H8, we can take 5 minus X. Why? Because methane plus propane are form the 5 liters. So when we can take the this methane X, then propane is called 5 minus X. So you can get the 5 minus X. Now my dear students, here we can see the 2 moles of oxygen, 2 moles of oxygen required for methane. This is reaction Y1. You can see the reaction 1. 2 moles of oxygen required by the methane. It means it is at 2x moles. Why? Because methane we can say the x moles of oxygen is required. Here in this reaction 2 moles of oxygen is required, so it is at 2x. Now we can see here, and 5 moles of 5 moles of oxygen required for C3H8. So my dear students, it is called, why this is 5 moles of oxygen is required, so it is called 5 minus 5x. Because 5 moles of oxygen is required, here you can see the equation. 3 2s are 12, 6 oxygen, here plus 4 oxygen. So 6 plus 4, 10. So here 5 2s are 10. 5 moles of oxygen is required by this 1 mole of propane. So here we can see 5 moles of oxygen required for propane. So, it is a 5 into, we can take the 5 minus x, 5 minus x. My dear students, 5 mole of oxygen is required for propane. So, it is called 5 into 5 minus x, and 16 liters oxygen is required, and 16 liter, it is given in question, 16 liter oxygen is required for combustion of methane and propane. Because my dear students, when methane and propane are combustion in the presence of oxygen, you get heat in Bunsen flame. So, 8 and 16 liter oxygen is required. We plot this equation. In equation, you can get the 2x plus 5 into 5 minus x, that equal to 16 liter total required by the methane and ethane. Here you can see that 2x plus 5 5 is 25 minus 5x, that equal to 16. You can get the this minus 5x go here, 2x is also, and 25 minus 16 come here, both are one sided. This plus 5x minus 5x convert to plus 5x, and plus 2x is convert to minus 2x. When this 25 minus 16, you can get the 9, and that equal to 5x minus 2x, that equal to 3x. Now you can calculate the x is equal to 9 by 3. So, my dear students, you can calculate the x, that equal to 9 by 3. Now, my dear students, here we can say that moles of methane. You can also call NCH4. What is the moles of methane? Here we can say the moles of methane. 1 mole of methane, it means 22.4 liter. And here you can say that 3 moles of methane are present, because x is equal to 9 by 3, means that is the 3. So, x is equal to 3. So, you can see what is the x? X here, we can take the x for methane. So, x for methane here. So, you can call this 3 moles of methane. 1 mole of methane gives 22.4 liter gas. So, 3 mole of methane, that equal to 3 into 22.4 liter volume. Now, we can take the NC2H6 propane. Here propane, we can see here propane, that is the 5 into 5 minus x. 5 into 5 minus x. And we see the 5 into 5 minus x, and you can see the 5 x is equal to 3. So, 5 into 5 minus 3, that equal to 5 into 2. And my dear students, you can get the 5 minus 3, means that is 2. This is the 5 moles of oxygen is required, but we can see only number of moles. So, number of moles is the 5 minus x. So, my dear students, you can see here only 5 minus x. So, here what is the propane, that is the 5 minus x, 5 minus x is the 3, then you can get the number of moles 5 minus 3, that equal to 2. So, here 2 upon 22.4 liter. Now, my dear students, you can here calculate the number of moles of methane, ethane, and values of x. Now, we can see here delta H mixing, when both are mixed with each other. So, you can see here 3 upon 22.4 liter, it is mixed with, this is the heat of combustion, delta Hc methane plus 2 upon 22.4 liter multiplied by heat of combustion of propane C3H8. Now we can put the values 3 upon 22.4 multiplied by these values are given in your numerical 890 plus 2 upon 22.4 multiplied by the 2220, then you can get the delta H mixing, and my dear students, you can get the delta H mixing when you can solve. You can multiply 3 multiplied by 890 and divided by 22.4. 2 is multiplied by 2220 and divided by 22.4. Then my dear students, you can get the 317 kilojoule. When you can multiply and divide it, you can get this answer. And this is your answer, my dear students. Question number 36, you can get this answer. Answer is 317 kilojoule. Now we can further see this question. 5 liter of a gas mixture of methane and propane is perfectly combusted at 0 degree and 1 atmosphere. 16 liter of oxygen at the same temperature and pressure is consumed. The amount of heat released from this combustion in kilojoule. Amount of heat, that is 317 kilojoule. Here kilojoule. Delta H combustion methane 890 and delta H propane 2220. Now we can solve this question. This is the solution of this question. We can go to the question number 37. Enthalpy change for the reaction 4H twice H2 is minus 869.6 kilojoule. The dissociation energy of HH bond. My dear students, what is the concept of solve this question? Here, what is the bond dissociation energy? Bond dissociation energy is the required amount of heat to break 1 mole of bond. Here we can see we can break the 1 mole of bond. Here when we break the 1 mole of bond means H2, 2 gives twice H. Then this is called bond dissociation energy. Here you can see the in questions. Here this is a reverse of this question because here H2 is formation. So you can reverse this section, and when you can reverse this section, you can get this section, and plus 869.6, you can get this section, and here you can get the 2 moles. So this values is divided by 2. Then my dear students, you can get the 869.6 divided by 2. Then you can get the 434.8 kilojoule. So you can get the answer C, question number 37. It's a very simple question. We can reverse this values, and because bond dissociation energy calculated for 1 mole of bond, and here you can get the 2 moles of bond. So divided by 2, and you can get the 1 mole of bond. This question is asked in 2011 NEET exams. Now my dear students, we can go to the question number 38. Question number 38, here this is the same type of questions in which you can see the from the following bond energies. You can always see delta H of the reaction that equal to summation of bond energies of reactants minus summation of bond energy of product. You can apply this formula, and what is the reactant? Here you can see the reaction. In this section you can see 1 double bond, these are the reactants, and in these reactants what are the bonds are present. Here you can see the CH bond 1, 2, 3, 4. 4 CH bond are present, plus you can see here 1 C double bond C present plus 1 H bond is present. Now, this is the reactants. Now, we can minus the bond energy of product, minus summation of product, and in product 1, 2, 3, 4, 5, 6. Here 6 CH bond is present and plus 1 CC bond is present. Now, my dear students, you can put the values which are given in your numericals and get the answer. Now, we can see here CH bond, we can put the values. Here, how many CH bond present? 4. So, 4 multiplied by the CH, 410.50, 410.50, you can multiply plus carbon, double bond carbon, this is the 606.10 plus HH bond, the bond energy is 431.37 and this whole is added and minus by this, these are the reactant minus product. The product 6 into multiply the CH 410.50 and here this is the plus single bond C, that is 336.49. Now, my dear students, you can calculate the delta H. When you multiply and plus and minus, then your delta H combustion, that is minus 120.02 kilojoule per mole. Now, we can see here, this is the answer B, question number 38, you can get the answer B. You can put this in this type and get the bond, enthalpy of bond, this will be enthalpy of the reaction. This is enthalpy of the reaction. Enthalpy of the reaction. Now, you can get the enthalpy of the reaction by this formula. Now, we can go to the question number 39. Bond issue enthalpy of H2, Cl2 and HCl are this and enthalpy of formation of HCl. Now, my dear students, what is the concept and reaction? First of all, you can formation the HCl. HCl is formed by half H2 plus half Cl2 to give 1 mole of HCl. And he wants the enthalpy of formation and he gives the bond dissolution enthalpy of H2, Cl2 and HCl. My dear students, when you can get the bond enthalpy of HH, 434, bond enthalpy of ClCl, that is 242, and bond enthalpy of HCl, that is 431. This is delta HF, because here delta HF is equal to delta HR reaction. So, you can see here, this is the sigma of HR minus sigma of HP. Here you can see the sigma of HR. Here you can get the 434 divided by 2 plus 242 divided by 2. This is the reactants minus, here this is the product, reactant minus product is HCl and HCl is minus 431, because you can get the only one HCl and here this is the bond, this is enthalpy of HCl, directly you can get the 431. So, my dear students, you can solve this equation, divided these values and minus plus, and when minus plus you can get the answer, that equals to minus 93 kilojoule per mole. So, you can go to the question number 39, option is A. Now, we can see the question number 40. Here my dear students, question number 40 is the direct, because enthalpy of formation you can get, and my dear students, when you can added all the equations, here you have not added all the equation. Why? Because my dear students, here he want the enthalpy of formation. What is the enthalpy of formation? When 1 mole of water is formed by its constituent half H2, sorry, H2 plus half O2. This is the H2 plus half O2. Then you can get the water, and this equation is present in A, H2, B, second H2 plus half O2 to give water liquid, and you can get the delta H minus X2. So, this is the same reaction. So, my dear students, this minus X2 kilojoule per mole is the bond enthalpy of formation. So, your answer is D. It is a theoretical questions and conceptual question. So, my dear students, you clear your concept and theory, then you can get this type of questions, because these questions are asked in NEET exams. This is asked in NEET 2007 exam. Now, we can go to the question number 41. Here this question is same, bond enthalpy of HCl he want, and you can concept and reaction, you can write here reactions. Bond energies of HH, here 1 mole of HCl is formed by half H2 plus half Cl2 to give 1 mole of HCl, and he want the bond enthalpy. This heat of formation of this, yes, he is given minus 90 bond enthalpy of HCl, minus 90 kilojoule. Now, we can see here delta enthalpy of the reaction, that equal to summation of enthalpy of reactants minus summation of bond enthalpy of product. Now, we can see here enthalpy of the reactant, that is half, here H2 is given, that is 430, you can take the 430 bond enthalpy of hydrogen plus chlorine, you can take 240, because here half we can done minus product, and you can get the bond enthalpy of product, that is HCl. HCl is H2, Cl2 and HCl. You want the HCl bond enthalpy, you want, and here it gives the enthalpy of the reaction. So, minus 90 is put here. So, my dear students, bond enthalpy of HCl is, when you solve these problems, because you only calculated this HCl, then you can get the 425 kilojoule per mole. Only calculation is there. When half of this 430 plus 240 you can add, and get that HCl, you can get the HCl, finally you can get the 425 kilojoule per mole. So, my dear students, you can see the 8 divided, and here this HCl is go equal inside positive and here plus, then you can get the 425. In this way you can solve it. So, my dear students, answer is B for question number 41. Now, we can go to the question number 42. The absolute enthalpy of neutralization of the reaction is. Here, my dear students, you can see here the what is the enthalpy of neutralization concept. When 1 mole or equivalent when one equivalent weight of strong acid is neutralized by the one equivalent weight of strong base, then amount of heat is liberated is called enthalpy of neutralization. Here, my dear students, for example, 1 NaOH strong base, 1 mole of HCl is neutralized to give 57.3 kilojoule of heat, and delta H is the minus 57.3. But when you can get the weak acid or weak base, when you can here take the weak acid and weak base, then enthalpy of neutralization is less than 57.33 minus Q. So, it is a less than 57.33. So, my dear students, you can see here MgO is a big base, then NOH. So, here twice HCl, heat of neutralization is less than 57.33 kilojoule per mole. Now, we can go to the question number 43. Here he want the bond energies are given, and this is the reaction is given, and he want the heat of reaction. So, then we use the concept and reaction. Here delta H reaction is equal to summation of bond enthalpy of reactant minus summation of bond enthalpy of product. My dear students, here H2 plus Br2 to gives to as HBr. So, we can see here summation of HH plus Br minus 2 into HBr. So, we can take here 433 plus 192 minus 2 into 364. Now, we can take 625 minus 728, because when it is multiply you can get this 728 and plus you can get this. So, heat of reaction, you can get the heat of reaction that equal to minus 103 kilojoule. So, my dear student, your answer is D, and you can solve in this way by this formula. This formula is also used in before exam. Same question is there, but you can see here 2 moles of HBr present. So, you cannot take the 1 mole, you can take the 2 mole in product, number of moles are same. Now, we can see here question number 44. This is the theoretical question which is asked in NEET 2020. Question number 44, for the reaction twice Cl to give Cl2 gas, the correct option is. Here, my dear students, what is the concept? Here in reactant side you can get 2 moles, and in product side you can get 1 mole. So, number of moles are decreases, number of moles are decreases, number of moles are decreases, means delta S decreases. So, it is a delta S less than 0. Now, new bond is formed. So, heat is liberated, means delta H is greater than 0, heat is liberated means plus Q, and plus Q means delta H is opposite. Means delta H is positive, it means it is a delta H is negative, because heat is liberated, here plus Q is obtained. So, delta H is negative. So, delta H is negative and delta S is negative. So, my dear students, question number 44, your answer is D. Delta H are negative, delta S is negative. Now, we can go to the question number 45. In which case change in entropy is negative? You can see here concept. Entropy of solid is less than the entropy of liquid. Entropy of liquid is less than the entropy of gas. Here, when sublimation solid to gas, entropy increases. Expansion of gas, molecules are displaces far away from each other. So, its entropy increases. Evaporation of water, liquid is converted to gas, entropy is increases. So, your answer is A. Why? Here these are the atoms and this twice H and H, both are different atoms. So, entropy is more, and when both are formed of molecules, means you can get one molecule. So, here two atoms and here one molecule, here you can get the two atoms. So, my dear students, entropy is here, entropy is decreases as well as enthalpy is entropy is decreases, entropy is negative. So, my dear students, now we can complete this chapter thermodynamics. You can see all the questions with concept and with the formulas. When you can solve these questions and you can learn these concept, tricks and formulas, my dear students, coming question you can easily solve that. Thank you very much.